G'day guys and gals, welcome to lesson 15, the final Python video for this topic, and we're going to be talking about version control. Now, this video is essentially about Git, so if you've ever heard of GitHub or anything similar to that fact, that's what we're talking about today. Version control is the idea of backing up your code and tracking multiple versions of your project throughout. Now, the benefit of version control is not only do you keep every single version of your program and you've got multiple backups, it actually enables multiple programmers to be able to work on the same project, and it gives you tools essentially to work out what's called conflicts when there's lines of codes that don't sort of mesh together. There's also the ability to branch off the main branch or the main source code to allow you to try out different changes or add different features. And when they work, you can merge them back to the main project. And finally, you can track changes throughout your entire project, especially if there is multiple programmers. Being able to track what has changed from the first to the second to the third version is incredibly beneficial. So we've got a bit of terminology that we're going to talk about, and I'm going to quickly go through those just to try and get your head around it. And I've included these icons less to say what each program looks like and more to just give you a visual in your head when I mention these things. So a repository, also known as a repo, is essentially your project. It's your files, it's your folder, it's your data. It is the collection of things that you can consider to be your project, which is where all your source code and data lives. So that's what this little symbol here is representing today. The next one, push. It is how you upload your repo to online or remote services such as GitHub. Okay, I'll talk about the difference between Git and GitHub very soon. Pull is downloading those changes or any other changes other programmers have made to your local computer. So you've got a copy of the project ready to go. Stage is getting things ready to be pushed. And commit is saying, here is a brand new version of my program, and here's a message that goes along with it to say what I changed, and it's then ready to push up to your remote service. And lastly, a branch is like a timeline, okay? If you think of like version 1, version 2, version 3, version 4 to be like, how do I say this, events in your program's history, then a branch is like an alternate timeline. So this is your main timeline. You've got version 1, 2, and 3, and you want to make another branch. Well, it comes down here and it makes a whole new timeline for your program from that point down. And then you can go back and merge the timelines together. Things get very tricky, and that's where conflicts happen and all that kind of stuff. But anyway, so these are the main terms. Repo is your project. Push is upload. Pull is download. Stage is get ready with it. And then commit is let's store all of our stage changes with a message, and branch is when we're like, want to add something that doesn't affect the original timeline of events. Okay, so here is our process. I'll move out of the way a little bit. If you think of your computer in the middle, this is a little bit of a complex process to get used to, but it becomes quite simple once you get used to it. So you're working on your project. It's sitting on your computer the whole time. You're tapping away. You're running hundreds of lines of codes. It looks beautiful, amazing. You're running graphics. You're creating font files. You're putting it all together. You've got a wonderful application. Well, then you go, all right, this version is done. The main core features are ready to go, and people can start testing this program. What you do is you stage all those files together and you commit them with a message saying initial version done, or something similar, or main menu finished. Okay, and that is staging and committing, which is then stored on your computer. Then you start working on the next thing. You're gonna go, okay, let's work on the, I don't know, level 1 of my video game. So I'm gonna chip away, I'm gonna start adding some data files here and there. I'm gonna add in the functionality so we can actually move around my first level, that kind of stuff. And you go, cool, I'm done. Well, then you stage those files that you've changed, you commit them, and that version is stored onto your computer as well. So this process continually repeats itself again and again and again. And it stores every single version. So if you're like me and you corrupt something, or you lose something, or you go, crap, what was that code that I wrote 3 months ago when I was in a bit of a daze and it was amazing, and then I decided to delete it for whatever reason? Good news. All your versions are stored. Every time you commit, those changes are stored within your computer. And the really cool thing, the way version control works is it only commits or stores the changes that are made. It doesn't make a copy of them every single time. So it doesn't become huge and bloated. It's actually quite slim in the way that it works. Now, at every stage, when you make a commit, you then have a choice to push it up to a remote repo, to share it with other people, to make it open source, or to even create just your own backup. If you want to create a private cloud repo, you can do that. And that's what push does, okay? It pushes it up to services like GitHub, Bitbucket, all those kind of things. And then when you go home and you're on another computer, you can then pull those changes that you pushed up to the cloud onto your computer, and then you start making new commits every single time, okay? So it's a little bit more complex than, say, just uploading a file to Google Drive and then downloading that file when you get home, because it's got this and this all together. But because it works so efficiently, because it backs up every change you've ever made, and it doesn't store the file copy every single time, only the changes, it actually makes things very efficient. So, goods and bads. We've got 3 ways of making backups, okay? And I always get this question every single year. Why can't I just use my USB drive? Well, you can. I wouldn't recommend it, but you can. However, there are goods and bads in every method that I've seen in life. There is the Git method, which I'm talking about here. This is the version control. There is the cloud method, and there is the local method, like using a hard drive or just saving to your computer. The advantages of Git are huge. They are vast. And the disadvantages sometimes outweigh it, but let's get into that. For Git, it stores every single version you commit into your repo, okay? And if you upload it to a remote repo, it's accessible anywhere you've got internet access. So if it's on GitHub, then you can get it anywhere. You just need to make sure you have a Git program or a program to download, which we'll talk about soon. You can collaborate on those things now. You can make branches to go off your main timeline to make breaking changes and then merge it back in when it's great, or delete it when you hate that timeline. You can upload, it only uploads the changes you make as opposed to the raw files every single time. And it provides that local and that remote storage. So if you have no internet connection, it's still on your computer. You can still work on it, okay? It's still technically a local copy. The disadvantages are it is much more complex, okay? You have to learn about all these concepts of committing and pushing and pulling. And if you forget to push when you're at school and you go home and you go to pull and you go, I haven't got my local changes, you've got to really, it makes things a bit more complex, unfortunately. And the final thing is you need to deal with the conflicts when you collaborate. If 2 coders are working on the same file and they make changes to very similar lines, the program will say there are conflicts in this file and I will not commit or upload or merge these changes, they're called, sorry, until you deal with the conflicts. Whatever. That's something you have to deal with. Cloud. What's the benefits? Well, it stores all the versions of your files, okay? If you're using Google Drive, every copy you upload, it's a raw copy every single time, but the previous version is also stored in the background, okay? You can access those previous versions. And you can access them anywhere you've got internet access. So your phone, your tablet, whatever. It's really good for that. And the files can be shared as well. The only problem is, typically, with a Google Doc, you share it and you can collaborate live on it. With code, it doesn't tend to work. There is a thing called Live Share, but that's more a feature of Visual Studio Code as opposed to a cloud feature. The thing about clouds is they don't support branches. It is very difficult to collaborate, especially if someone deletes a file or changes a file that you really need. And it's much slower because uploading those files and downloading those files, it's the raw versions of those files. So if you've got 10 gigabytes, it's downloading and uploading that 10 gigabytes every single time. Next one, what about the local hard drive? Surely that's heaps quicker. Yes, it is. It is much, much quicker than the remote methods of cloud and the remote Git. However, all it does is store your files. And unless you have a separate backup system that you make yourself, you get 0 backups. Okay, you don't get to store every version. You don't get branches. It's only accessible there. So if you forget that USB stick at home, you don't bring it into school, you're screwed. If your computer dies, it's gone. Okay, and again, you need to manually back it up. So there's goods and bads for all this kind of stuff. Moving along, GitHub. What is the difference between Git and GitHub? Because you've probably heard of both. Git is the technology for version control. It is the thing that is pushing, it is pulling, it is committing. GitHub is a website or remote server where you can upload your projects and share them with others, or even upload them and keep them private these days. Okay, it's owned by Microsoft, and yes, that is called Octocat, because if you look at the full picture, he has octopus legs. Microsoft is sort of hiding it these days. I don't know why. Now, if you don't like Microsoft and you want to avoid them like the plague, there is Bitbucket, there is GitLab, there is plenty of them out there, and most applications will support this thing. Will support those websites. Don't know why I said this thing. All right, last thing, let's set up a repo in our computer, let's commit to it, and let's get it pushed up to the cloud just so you can see what it's like to use a Git project. So the first thing we're going to need to do, everybody, is we're going to need to download something to manage our projects. There is GitHub for desktop, there is SourceTree, there is hundreds of them. Okay, I personally use SourceTree, but we're going to use GitHub Desktop today because it's so much easier to get started and it integrates quite nicely with Visual Studio Code. So we'll download it. Let's get it installed. Anytime. Okay, and here we are. So, welcome to GitHub Desktop. The first thing you're going to do is you're going to sign in or you're going to create an account. I already have an account, so I'm going to quickly log into that and then show you the next step afterwards. Otherwise, create it. You can skip that step, but what that means is you can only create local Git projects. You can't create remote ones. And I want to show all of it. So create an account and just do that. Okay, I'm going to pause and log in. See you soon. Okay, we're back. So once you've logged into your account, it's going to throw you back into the screen. That's going to say, what's your name, what's your email, and there's an example of what it's going to look like. So for me personally, I'm just going to use my full name, and that's my usual go-to email for these kind of things. And that's what it's going to look like. Good for me. That's fine. When you're in, now these are all repositories that are remote, that are sitting on the GitHub server. But what I want to do is I want to create a brand new folder, and we're going to start putting source code into it, and we can monitor what it looks like in GitHub for desktop. So let's create a brand new repository. What are we going to call our project? For this one, it's going to be maybe a choose your own adventure. And as you can see, it's telling us that it doesn't like the spaces. It's going to do dashes instead. That's fine. I'm not going to do a description because I can't be bothered. Folder. Where are we going to store it? I am still going to store it on the cloud. I know that sounds weird, but I like to store things on the cloud as well. All right, git ignore. So a git ignore is amazing to use. What it will do is sometimes when you're creating projects in certain languages, especially things like Unity, there's a lot of junk files that are created in your projects. And you don't want to have to upload all those junk files because you're never going to use them. You're never going to, require them. So you use a git ignore to ignore certain types of files. So I'm going to go down and we're simply going to choose Python. And what that'll do is that's simply going to ignore some of the files that are generated by modules and things like that. But don't worry about it too much if that doesn't make sense. License, I'm not going to worry about a license. We're going to have a no license project. All right, here is the main interface. So the left-hand side is going to show any files that change within that folder I created called Adventure. Okay, there is a history, so I can look at my entire timeline of events. And then the right-hand side shows you details about what's going on. Let's open this in Visual Studio Code. Why not? How good's that? I love that, being able to open it up. There's those Git files I was talking about. There's the attributes and the ignore. So there's a whole bunch of things that are being ignored, but I don't care because it's done it for me. I love it. So I'm going to make a file. I'm going to call this main.py. And so Welcome to my amazing game. Choose your class. Let's create. Still not used to this keyboard. A warrior. A wizard. And cleric. Why not? Okay, so there's my amazing game. This is all you can do so far. 0 interaction, but I don't care. I'm going to make a new file up here. We're going to call it warrior.py. You are a warrior. Okay, we'll make another one, obviously called wizard. And you are a wizard. And then finally, what do I call it? Cleric. Is this the best way to code? No, but I want to show you some things off. Notice all these things that are now appearing. We've got greens, we've got the letter U, we've got this stuff down the bottom, main. What the hell is going on? Well, Visual Studio Code has recognized that this folder is being monitored by Git. And great thing is Visual Studio Code actually has lots of built-in functions for this kind of stuff. In fact, right here, it's tracking those changes. It's tracking our new files. It's tracking the lines of code that we write, that we delete, that we change. Okay, so let's quickly jump into GitHub for desktop. And notice it's indicated there are 4 change files. The plus simply indicates these files have been created. What is the summary? Main menu. Yeah, we'll just call it main menu complete. I've completed the main menu. The characters are currently just stubs. Then we hit commit. So keeping in mind, these are all ticked. So these are staged changes. If you don't want to stage one of these files because maybe it's just temporary, you can untick it. So now there are only 3 staged changes to this commit. But I'm going to leave them all ticked. I'm going to hit commit to main, and you'll see all the changes will disappear. But if I go to the history, you'll see what actually has been changed between all these different commits. Let's say I go back in, you'll notice that all that goes away because, again, code recognizes that you've made all these changes. Let's say I don't actually want wizard in my game. I want it to be a rogue. Okay, and then I'm going to rename my wizard file because that seems like the logical thing to do. RNG. And then you are a rogue. And I don't like to choose the amazing game, so let's delete that for now. All right, so you can now see all these changes. So U is I've updated something. M means I've made some changes or modified it. So let's go back and have a look. To changes, red indicating I've deleted it. Green meaning I've created it. Orange meaning I've changed it. Okay, so like so. Removed wizard class. Don't have to put a description if you don't want to. All right, as you can see, I've now got my new commit. All right, so everything I've just done is showing you how changes are tracked and how you actually stage and commit those changes. But I haven't shown you how to push and pull. Well, the first thing, in order to do that, I have to have a remote repo to put it on. Now, because I've logged into my GitHub account here, inside GitHub for desktop, it comes up with this lovely button here. If I click on publish, it's simply going to say, what is the name of your remote repo? Do you want to describe it? And do you want to keep it private? I do. So let's publish it. Okay, give it a second. As you can see, it's creating that new repository and it's automatically pushed all the changes up to the cloud, like so. And anytime I'm on another computer and I make a commit and I push those changes, I simply have to go back to my other computer and click on the sync button and it does the pull. It does a push and a pull automatically for me. It's really goddamn handy. So this is, again, something you really need to just play around with. Have a go at playing with Git, because realistically, when you start creating big projects, start by using a Git straight off the bat. All right, it's really handy to track all those changes, to make multiple versions, all that kind of stuff. If you've got this far and you've watched every single video so far, not only congratulations, I hope you've learned something so far, because that's the end of the Python videos. And the next video, we're actually going to get into our theory of starting to design our software. So thanks very much for watching, everybody. Hats off to you. See you in the next one.